Okay, so here's your target 7 and 8 homework. So just like on your notes, we're going to start off by solving um, these inequalities, and then we're going to graph them on the number line for the first two. So the first thing I'm going to do is combine the negative 4x minus 4x to get negative 8x is greater than or equal to negative 16. Going through the solving process by dividing by a negative, you guys know that you have to switch that inequality symbol, and that would give me a positive 2. So I solved the inequality, and now I'm going to plot it on the number line. So at 2, it already labeled the number line for us, so that makes it easier. We're going to include 2, and it says x is less than, so I'm going to shade to the left. On this next one, we have a little bit of distribution to do first, so distributing the 8, and then the negative 2. And then I'm going to combine like terms, so on this left side I have 8v and 14v, so I'm going to combine those to say 22v. And then combining these two to negative 26 is less than 62. I'm going to add the 26 over. So I have 22v is less than, that gives me 88. And I don't have to worry about switching the symbol this time since it's a positive number we're dividing by. And that would be v is less than 4. So at 4, we're going to make an open point since it's not included, and it says less than, so again, we're going to shade to the left. So on 3 and 4, it doesn't have a number line, but we're going to keep just solving like we were above. We just don't have to graph it on a number line. So I'm going to start by distributing the 4. And combining like terms, so I have negative 5n and 32n, which gives me 27n. I'm subtracting the 4, so 27n is less than, that's negative 162. If I divide by 27, I don't know what that is off the top of my head. Let me grab a calculator. So I get n is less than negative 6. Again, I don't need to graph this one. So on number 4, I'm going to distribute the 4. So combining the x's, that gives me 30x. And I'm going to subtract the 4 over. So I get 30x is less than or equal to, that would be negative 90. Dividing by 30. I don't have to switch the symbol here because the number I divided by is not the negative. So we get x is less than or equal to negative 3. On the back of your homework, we're graphing linear inequalities. So we're going to start by the same way we would graph a line. I'm going to think about what the slope and the y-intercept are on number 1. I'm going to use that to help me graph, so starting at negative 4 and a slope of negative 2, so make sure your line's going downhill. Also be thinking about, should your line be dotted or solid? In this case it is going to be dotted since it's just less than, not less than or equal to. And then you can either use the fact that this is less than to know that you're going to shade below, or if you wanted to use a test point, plug that into your inequality, so you would have 0 is less than negative 4. 0 is not less than negative 4, so we're actually going to shade the portion of this graph that does not include 0, 0. On the next couple examples, I'm going to actually not use a test point. The earlier you can get away from a test point, probably the better, just for some topics that we have coming up. So in the second one, slope is 1/2. y-intercept is -5. So graphing those, make sure your graph is going uphill with a positive slope. And again, this is not equal to, so we're going to make a dotted line. This says y is less than, so we're going to shade under this graph. So right in that region. So notice on that one I didn't use a test point. And again, just start thinking about, could I do this without a test point using the inequality symbols? All right, on number 7, our slope is -1. Our y-intercept would be 0 because this is like a +0. So go ahead and start plotting that. I'm going to skip some points here just so they're not so close. And yet again, we have a not equal to. So we have a dotted line, and it says y is greater than. So I'm going to shade above the line. If you were using a test point, make sure that you didn't use 0, 0, just because 0, 0 is on the line. Remember, you can't use any points that fall on the line. Last one, slope of -5, y-intercept of -1. Let me go ahead and plot that. This is a super steep line. And this one is our first solid. It's a little wonky, that's okay. Now this is a great example to think about, like can I tell what's above and what's below? Because it says y is greater than or equal to. But for me, it's kind of hard to tell what's above when I think about greater than when the line is so steep. So you can always fall back on a test point. It's just nice to have different strategies. And again, 0, 0 is really close to the line, so I'm going to choose something like 6, 0. And if I plug that into my inequality, I would have 0 is greater than or equal to -5. The x value is 6 that I've chosen. So I have 0 is greater than or equal to, that would be -31. That is a true statement. So 6, 0, which is over here, is a true statement. So I'm going to shade the side with 6, 0. And there's your homework for target 7 and 8.